I want to invite you to take a breath and imagine the night sky. Not the sky you might have seen last night, with a handful of stars struggling through the clouds or through the glow of the city. I mean a sky so full of celestial objects that it feels alive. A sky that our ancestors looked up to in wonder. A sky that guided their journeys, told them stories, and helped them to understand their place in the universe. Hold that image for a moment. Now I want you to imagine the same sky again, but this time, imagine that half the stars have vanished. Not because clouds rolled in, not because your eyes changed, but because the sky itself has been transformed. And that transformation is happening right now. And most of us never see it because the change is quiet, invisible, silent, until suddenly it isn't. When I was a child, growing up under clearer skies, I used to lie on the rooftop of my house at night, completely still, staring at the heavens. And it felt like falling into something infinite. Those night skies shaped the person I am today, whispering questions that eventually led me to become an astrophysicist. And I'm not alone. Most of the world's deepest stories began simply by looking up. For our ancestors, the skies were so full of celestial objects that constellations weren't made from stars. They were shaped by the dark patches in the sky. And those shapes, those stars, those constellations, they carried profound meaning. For the first peoples of Australia, constellations marked the rhythm of the seasons. For the Mapuche communities in Southern America, they indicated creation and balance. In Greek mythology, the Milky Way is said to have formed when Hera pushed away the nursing infant Hercules, spilling the milk, creating the Milky Way and giving us the word galaxy. For the Persians, the Milky Way was the kings, a river of stars guiding travelers and heroes through the night. Different cultures, different languages, the same sky, the same companion for every civilization. And now we face a question none of them had to ask before. What story we will leave behind if that sky disappears? Before I go on, I want to acknowledge something really important. Most of the light that drowns our skies still comes from Earth, from our cities, from our street lamps, from our built environment. But even as communities work together to dim that glow, a new source of sky glow is rising. And this glow reaches every horizon, even in the darkest places of Earth. And I want to pause here, because this is where the story becomes complex. The fading of the night sky isn't caused by something we fear. It's caused by something we rely on: satellites. Satellites are woven in every part of our modern life, often in ways we don't notice. But before I go on to explain how they are affecting our night sky, I want to honor the benefits they bring. So now, let me be clear. Satellites are extraordinary. They help us track hurricanes before they strike. They connect people in remote areas with the rest of the world. They guide airplanes. They protect crops. They help us observe and monitor our changing climate. Satellites even keep global finance running, providing precise timing, communication links, and all the real-time data that every international transaction requires and depends on. But powerful technologies, even brilliant ones, come with side effects. As thousands, soon tens of thousands of satellites are launching to orbit, it's worth mentioning that we've launched more satellites in the past 5 years than in all the decades of a space age combined. And these satellites, they reflect sunlight down to Earth. Their glints sweep across the sky. Their trails cut through astronomical images. And together, they create a glow, an artificial haze that brightens the night sky everywhere. Even in the world's darkest places, remote deserts, mountaintops, sacred lands, the sky is getting brighter. And astronomical images are oldest and most precious cosmic records are being really damaged by satellite streaks. Imagine trying to read an ancient manuscript and someone drags a highlighter across the page. This is what satellite streaks are doing to our oldest cosmic records. And it's not only an astronomer problem. No. This is a scientific problem. Satellite constellations overwhelm the faint cosmic signal from the past and future that the universe is sending us. It's an environmental problem. Increasing sky glow and artificial light pollution disrupt wildlife and even affects observations of our climate from orbit. And it's a cultural and social justice problem. Because the natural sky, once shared by everyone, is becoming something only a few can afford to see. But here is the beautiful part. This is not a hopeless story. What if satellites didn't need to shine at all? What if we could keep all the benefits without losing our night sky? What if the solution is not in the skies, but here on Earth, in the materials that we have? I'm leading a team at SARI to answer a deceptively simple question with enormous consequences. Can we keep satellites without disrupting our night skies? Can we keep all the benefits of satellites? And to do that, we began with a very basic set of questions. How do satellites shine? How do they scatter sunlight? how do they glow? Not just in the visible light, but across the whole electromagnetic spectrum, from optical glints all the way to radio leakage. And this matters because satellites don't pollute in just one way. They leave streaks on telescope images, they brighten the background sky, they interfere with radio communications, and as their numbers grow, these effects compound. One satellite becomes 10, 10 becomes 10,000. So my work begins with understanding every way a satellite can disturb the sky. To do this, I lead a team of material scientists, engineers, data scientists, and astronomers working together to map satellite emissions. The optical light they reflect, the heat they re-radiate, and even the unintended radio noise they leak into the atmosphere. We build physics-based models that predict how a satellite will appear in the sky at every moment. How bright it will be, how fast it will move, how it's going to affect possibly an astronomical image. We then pair those models with artificial intelligence systems that are physics-informed neural networks that learn from real telescope data to forecast satellite interference in real time. Think of it like a weather forecast, but instead of predicting clouds, we are predicting satellite glints and radio bursts. But understanding the problem is only half of the story. The real question is, how do we fix it? And this is where the work becomes genuinely exciting. I team up with one of the creators of the world's darkest materials. And together, we're testing this coating material that is designed specifically for satellites. This material absorbs sunlight like a sponge instead of reflecting sunlight back to Earth like a mirror. And we test this in the lab under very extreme conditions. We test it under intense radiation, vacuum temperatures, changing angles of sunlight, similar conditions that the satellite will experience in space. And we measure how dramatically the coating reduces the reflectivity. And we're not stopping in the lab. Next year, we're hoping to launch the first in-orbit experiment. It's one of the first real attempts to make satellites that respect the night sky. So sustainability is built in. It's not an afterthought. This is not a perfect solution. The coating is not going to remove every glint, and real change still depends on global cooperation, but it's a very important first step. But the coating is just the beginning. We will build a record of how every satellite in the sky is and how they bright and how the brightness changes. This database will support observatories, will inform regulators, will give industry guidance, and also will empower people like you, ordinary citizens, to participate in monitoring the night sky. And all of this, the modeling, the AI, the material science, the governance, everything is coming together in a larger effort to preserve the night sky by rethinking satellites for a sustainable future. And this is not science fiction. This is happening right now. What will be put into orbit today will echo for generations. We can choose a future where the sky slowly disappears under a halo of human-made light. Or we can choose a future where responsibility and innovation work together, where satellites support life on Earth and respect the night skies. So, tonight, when you step outside, weather permitting, look up, see how many stars you can see, how many are missing, and think about the fact that this is the oldest ancient message that we got from our ancestors. It's our heritage, and those who come after us deserve to inherit the night sky. This is our oldest shared story. Let's make sure it has a future. Thank you.